outrageous blue sky learning experiences. Among those are to design, build, test, and fly CubeSats. Dylan is one of our youngest students. He recently turned 12, and he and his brother, they wrote this paper. So my job is to introduce Dylan, and I'm going to sit down.
One of the CubeSats that we're currently working on has a mission to investigate a novel solution for plastic waste. This mission is important to global efforts in achieving sustainable development. But what is sustainable development? This concept is still new to our society. In 1987, the United Nations defined sustainable development as one that meets the needs of the present without compromising the future generations to meet their own needs. Through this report, the three interconnected pillars of sustainability were established: the economy, society, and environment. The report states that in order to ensure sustainable development, all three pillars must be considered. As we look at global plastic production, we must understand its consequences. Plastics have become an essential part of our lives, but ever since the 1950s, global plastic waste has increased by over 350 million tons. Global plastic production is also a major contributor to global greenhouse gas emissions and climate change. So as we build interplanetary societies to escape the problems of planet Earth, we must build a framework to manage pollution problems in outer space in order to prevent the same similar crisis from occurring there. So what is the role of space industry in sustainable development? Many space agencies recognize that they play an important role in facilitating sustainability in Earth and in outer space. For example, the United Nations Office for Outer Space Affairs works to accomplish sustainable development through their program called Space for SDGs. And NASA is using their unique space capabilities to increase awareness about planetary sustainability. NASA also builds partnerships with educational organizations who can help think of solutions for environmental problems. For example, through NASA's CubeSat launch initiative, our Wolfpack CubeSat development team is able to work on satellites with important research missions, such as the WolfSat-1. The WolfSat-1 is a 1D CubeSat, which is a small satellite measuring 10 by 10 by 10 centimeters. WolfSat-1 will have an educational mission for students such as myself, as well as a biological research mission to analyze Ionolis acantharis in the microgravity environment. Ionolis acantharis is a species of bacteria that has a unique ability to digest plastic in microgravity. We will investigate if this bacteria can survive in microgravity and investigate how microgravity affects its ability to digest plastic. If this bacteria can be proved to metabolize plastics in microgravity, then prolonged space missions will have another means of recycling otherwise single-use plastics. CubeSats consist of two primary sections, the fast bus and the payload. The fast bus is made up of all the subsystems that allow your satellite to function, such as electrical power systems and the communication systems, while the payload is the mechanism that carries out the mission of your satellite. In this case, our payload will be designed to measure how much polyethylene Ionolis acantharis can consume. To conduct our experiment, we'll be using light-emitting diodes. Once the bacteria digests the sample, more photons will be observed from our photon detector. Before launching this experiment in outer space, we will also conduct a ground test. This way, we can compare and analyze the tests conducted on ground and microgravity. The use of Ionolis acantharis can be an effective solution because it is able to grow on films of polyethylene and use it as a major energy source. This bacteria uses two enzymes to degrade polyethylene into carbon dioxide and water. The only problem with this process is that it is very slow. However, we believe the microgravity environment may accelerate this process. One study documented that various biochemical processes can be altered by weightlessness, such as enzyme activity. It was found that certain enzyme kinetics are enhanced by 25 to 30% in the microgravity environment. If Ionolis acantharis can degrade polyethylene faster in microgravity, It would be very beneficial for future recycling and future space science. According to the United Nations Economic and Social Council, sustainable development is the most urgent priority for the international community. And since nations are starting to create interplanetary settlements, it is even more important now to understand how we can implement sustainable development in outer space. But first, everyone must agree on what sustainable development actually means and how it works. The problem is there are many different definitions of sustainable development, but not one singular theory unifies them all. For example, one and the most prominent model of sustainable development is the 3 pillars model, where sustainable development is represented through social, economic, and environmental pillars. This model claims that sustainable development is achieved once all pillars work together in unison. However, as you can see on these diagrams, there are different ways that society has been interpreting these 3 pillars, which means there's a lack of clarity of how these pillars will work together. A recent study of historical sustainability literature claims that this is because there's no single point of origin of the 3 pillars conception. The study also claims there's no theoretical adequate description of the 3 pillars. This lack of clarity causes frustrations as the society tries to implement this concept of sustainable development. Another model of sustainable development, which is expressed in the form of a prism, claims that there are 4 dimensions relating to sustainable development: the economic, the environmental, the social, and the institutional dimension. In this model, sustainable development is achieved once all 4 dimensions are increasing in tandem. It is important that society establishes a unifying theory so we can teach the next generations on what sustainability means and how to achieve it. A unifying point of view is also important in space exploration. Otherwise, our future space settlements could repeat the environmental mistakes that have already been made here on Earth. This is where the concept of universalization comes in, because our planet Earth is part of the larger universe, and humanity is trying to establish interplanetary existence. There are major global efforts being dedicated towards innovation, but not enough efforts are being focused on discussing the principles by which the society will function. Nations must come together to develop a collective vision of space governments and policies to answer questions such as: what will happen when we actually get to space? How will society function? And how will we protect and preserve the environment of other planets so that we can prevent the same environmental crisis from occurring there? Environmental sustainability is one of the key issues that mankind is currently facing here on Earth. However, the more we look at the stars, we realize that this issue is bigger than just our planet. The future of the world is in a multi-planetary society where people of Earth can access the resources of their solar system. Therefore, we must not only focus on solving sustainability issues here on Earth, but we must also focus on preventing those issues occurring in outer space. Society must recognize that space exploration should play a key role in facilitating sustainability here on Earth. For example, we can utilize small satellites such as the IAC'21 to test novel technologies, which could help us preserve sustainability on Earth and in space. The small cellular revolution should and can play a major role in accomplishing planetary sustainability. Thank you. I'm ready for it.
Thank you so much, Dylan.